All right, guys, welcome to Unit 3. This unit is all about polygons and quadrilaterals, so shapes and sides with shapes with four sides. Okay, so if we start with this question, this is a polygon, which means it's a figure that has straight sides and angles, and it's closed, right? So there's no open gaping holes. Okay, and this question asks, what do all the angles in this shape add up to? So what it wants to know is, what is this angle? What is this angle plus this angle, right? All 8 of these angles, when we add them all together, what do we get? Okay, and that's a skill that we're going to need if, in case we have a missing angle or we're asked to find one angle. Okay, so we know a triangle adds up to 180, but for a shape like this, we don't know off the top of our head what all these angles add up to. And you can memorize it, but there's a much easier way to do that, and that's using the equation. Okay, so the equation we need here is n minus 2 times 180. Okay, and all n is the number of sides. So I'm going to go around. There are 8 sides on this shape, so all I have to do is plug in the number 8 for n. 8 minus 2 is just 6. 6 times 180. Okay, and we get 1,080, okay? And remember, that's not just one of these angles. That's this angle plus this angle, plus this angle, plus this angle, all the way around our shape. So even though this number seems big, it actually makes sense for our answer here.
Yeah, but if you do me, sometimes it whites out the board, so sometimes it's better to have. So we're gonna analyze a similar type of problem that Mr. Matthews just discussed. What do all of the angles in a 22-sided polygon add up to? So this is a shape where if we drew it, there would be 22 different sides, and that means there would be 22 different angles. And I want to know, if you add up all 22 angles, what's the total? And we're going to use that formula that Mr. Matthews just discussed, n minus 2 times 180. This is our go-to tool when we're talking about our interior angles, because this is talking about all of the angles inside the shape. So this is our interior angle formula. N stands for how many sides does the shape have. So I'll plug in my 22 times 180. 22 minus 2 is 20 times 180 will give us 20 times 180 will be 3,600, which means if I take all 22 angles and add them up together, we're going to end up with 3,600 degrees.
Okay, guys, so that equation that we were working on really helps us out when we have problems like this. I know this angle, this angle, this angle, and this angle, but I'm missing that x up there. And how do I find it? Okay, I'm going to need to start with that equation that we used before to figure out what all the angles add up to. Okay, because if I know the total and I know what these ones are, all I have to do is subtract and figure out what I have left. So let's start with that equation. N minus 2 times 180. N in this shape is not 121, it's not 68, it's still the number of sides, which in this shape is 5. 5 minus 2 is 3 times 180. All the angles in this shape have to add up to 540. Okay, so I'm not quite done on this one. I know that all the angles add up to 540, and it gives me some of the angles. So what I'm going to have to do next is I'm going to have to add up the angles that I've got to figure out what I have already accounted for. So I've got 68, I've got 121, I've got 103, and I've got 85. And all I've got to do here is add these angles together. 81, let's see, we got 9, 12, 17, 7, 8, 9, 17. We end up with 377. So is that angle 377? It's not, right? This is the total angles, and we know that with x it has to add up here. So all we're going to do is we're going to take this 377 and subtract it away from 540. And we end up with 163. So that's more than 90, but it's less than 180. Okay, so we know that that answer does make sense for x.
The last application of our formula, n minus 2 times 180, is going to come into play when we talk about regular polygons. Now, when we call any shape a regular square, a regular pentagon, a regular triangle, a regular polygon, means that we have all congruent sides and we have all congruent angles. So just by telling you that this is a regular polygon, you automatically know these 1, 2, 3, 4, 5, 6 angles are the exact same measurement. It's important moving forward. Because what the actual question is asking here is just what's x? What's the measure of just one of those angles? Well, first we need to figure out what's the total of all of those angles. So we're going to go to our trusty interior angle formula, because this formula always tells us what they all will add up to. So I'm going to count 1, 2, 3, 4, 5, 6, 6 sides for n. 6 minus 2 is 4 times 180. 4 times 180 will equal 720. So I know that all of these have to add up and equal 720. And since I know that all of the angles are congruent, they're all the same exact measure. So in this case, because I know it's a regular polygon, I'm allowed to take my total and divide it up into 6 nice equal parts. You're only allowed to divide it into 6 nice equal parts if you know all of the angles are congruent and the same. So if I do my 720 divided by 6, we'll get 120, which means that this angle is 120, this angle is 120, all of the angles inside of here are 120.